Okay, so here's what we're going to do, folks. I'm going to teach you how to draw, Kobe, every molecule known to man in the universe using these three simple rules. Now really, if you go by these rules, you'll be exactly right. But once you get enough practice, these three rules, okay, you'll be able to get it. First rule, all right? Hydrogen always outside, never in the middle. Hydrogen's too small. It always goes around the outside, never put it in the middle of anything. Rule 2, count all the valence electrons, okay? And octet rule, all atoms except for H want 8 valence electrons. How do we know how many valence electrons things have? Well, very simple, Macy. You look at the periodic table. How many does group 1 have? 1. How many does group 2 have? 13, 14, 15, 16, 17, and 18, 8. Now, very important. Helium in group 18 only has 2. It's too small. Everything else has 8. Okay, so let's put this to work. You have a sheet that I gave you. We're going to do a few warm-up problems on the back. Flip it over to the back where it's blank. Or else flip it over to the back where it's blank. We're going to write the molecule H2. Again, these are just covalent molecules. Do they have any metals in them? No, they do not. Okay? All right. So H's never go in the middle. We're going to count the valence electrons. How many valence electrons does hydrogen have on the periodic table? 1. But we have 2 of them. So what is that total? 2. So we have 2 total valence electrons. So I have an H here and I have an H here. So what is the characteristics of covalent compounds? Do they transfer electrons or do they share electrons? They share. So when I draw share, I'm going to draw a line between them sharing, and a line really represents 2 connected dots. What do those dots represent? Lexi? The electrons. Okay? So this is 2. This is 2. All right? 2 total valence electrons, 2 shares. That's it. Am I right so far, Shania? Yes. The next thing we're going to do is draw the molecule HF, hydrogen fluorine, or fluoride, hydrogen fluoride. Let's count the number of valence electrons. How many does hydrogen have? 1. How many does fluorine have? 7. What's 1 plus 7? 8. So we're going to draw an H, and we're going to draw an F. Okay, we're going to connect them, because they share. Remember, a line is a pair of dots sharing. Now, so far we've drawn 2. How many do we need to have? 8. We're going to add dots. When we do it, we're going to count by 2s to make it easier. So that's 2, that's 4, that's 6, and that's 8. Here's our octet rule. Octet rule. All atoms except for H want 8 valence electrons. Well, fluorine has 2, 4, 6, 8. H only has 2. That one's correct. That's what the molecule, that is called a Lewis structure. Okay? Let's get more complicated. What if I did this? What if I had H2O?
That sounds familiar.
H2O. What do we do next, Soros? We count the valence electrons for H2O. How many valence electrons do we have for H? 1 for H, 2 of them though. Plus, how many for oxygen? 6. What is 2 plus 6? 8. Okay?
If I'm gonna go write, I guess I need to write, I was gonna write it up. It's real simple. I'll write the paper. She can email, I'll write it up, or she can email me everything.
Yes, ma'am. Okay, so there's 8. Now, which one goes in the middle? Does hydrogen ever go in the middle? What's the rule say? Hydrogen only on the outside. So what has to go in the middle? Oxygen has to go in the middle. Okay? So put hydrogens on the outside. Why did we do that, Sydney? Because hydrogen never what? Never goes in the middle. We have to connect these because these are covalent. They share, right? They're right at the right of the red stairs. They share. They share. So we're going to draw a line sharing. That's 2. Another line sharing is how many?
4.
4. Okay. So 2, 4, and then 6, and then 8. I know what you're thinking. Why didn't I put more dots on hydrogen? The answer is you can't. You can't. Because the rule says all atoms except for who?
Hydrogen.
Can't put extra dots on hydrogen, ever. Can we, Shania? Never. Okay? Alright, how about another one? How about one more complicated? Is you ready? Huh? Nope. No, we're still doing it with hydrogen. NH3. What's the first thing you do? Add up what? Valence electrons. Okay, how many does nitrogen have? 5. Hydrogen is 1, there's 3 of them. So 5 plus 3 is? 8. Well, which one's going to go in the middle? Is hydrogen ever going to go in between anything?
No.
Never. So which one will go in the middle?
Nitrogen.
Nitrogen will go in the middle. Okay? So nitrogen goes in the middle now. We put hydrogen around the outside. Do they share? Yes. So that's 2. That's 4. That's 6. And then
2 at the bottom.
that's what? 8. Once again, why don't I add the extra dots on hydrogen? You can't. You can never add extra dots to hydrogen. Never. Next one. CH4. CH4. Okay? What do? Add up what? Valence electrons. How many does carbon have? 4. Okay? Hydrogen has 1, you have 4 of them. What's 4 plus 4? 8. Do you ever put hydrogen in the middle of anything ever? No. No, you do not. What goes in the middle here? Carbon. Hydrogens go around the outside. Around the outside. Around the outside. Connect them. Every time you connect them, how many is it? 2. 2, 4, 6, 8. We appreciate. Okay? Alright? Next. We are going to do one that's a little bit more difficult, Colby.
A 3 element.
No, man. Watch this now. Watch this. Okay, instead of NH3, let's do BH3. Let's do BH3. How many does boron have? 3. How many for these hydrogens? 3. That's total is what? 6. What goes in the middle?
B.
B. H is around the outside. Share. 2, 4, 6. Wait a minute. Uh-oh. I thought you said the Octet Rule. Thought you told us that they have to have 8. Why can't we have 8?
Because you only have 6.
Because we only have 6. We ran out. You can't have any more than you're allowed to have. What if we have a molecule without hydrogen, though? What if we did that? Would that be really difficult? Well, I don't know, Cam. I guess we've got to try. Ready? Here we go. B. Cl. 3. How many does boron have?
3.
How many does each chlorine have?
4.
Nope.
7.
7. There's 3 of them. For a total of how many?
24.
24. 24. 24 total, yeah.
That's a lot.
Okay, now you're probably wondering, what happens now? You said hydrogen doesn't go in the middle, so which one does?
Boring. No, boron does the middle.
Okay, now in our technical rules here, our list of technical rules, it says that the one that is less electronegative will go in the middle. So which one's less electronegative? Chlorines or borons? Borons are. What does that mean, Christian? Electronegative. Did we have a test on that?
I don't know who Christian is.
Tristan.
Or
We have a test on electronegativity, right? Yep. Boron goes in the middle. Chlorines go on the outside. Okay, here we go. Ready? 2, 4, 6. Now here's the most important part, class. Take my advice on this. I want you to watch this video. Start filling in your dots from the outside in. Okay? So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24.
That's a lot.
All right, we've got 24. Okay, but now Lexi's over there looking like, but you told us that it's supposed to get 8. And boron doesn't have 8. Okay, here, let me explain that. First of all, we've maxed out on electrons, okay? If we move electrons off of this one and put them here on boron, will that chlorine then have 8? No, it'll only have 6. Boron will have 8, but now chlorine will have 6. Which one wants to steal electrons more? Chlorine or boron?
Chlorine.
Chlorine does. Chlorine always wants to steal electrons. So it's going to have 8.
No, what if you had 26 electrons?
You can't add more than what you have.
No,
Period.
I'm saying like what, like if it was like BCO4.
Now hold on, Kobe. The fact that chlorine is so electronegative, more electronegative, means it also can't do this. It also can't share extra. Okay? Now, more advanced. Are you ready for more advanced?
No.
Yes.
Ready for more advanced? No? Yes? You don't know? You don't know. Let's go more advanced. Here we go. Oh my goodness. Let's do this. CO2. Does that look familiar?
Carbon dioxide.
No, you've never seen that before, Lexi. How many valence electrons for carbon? 4. Look on the periodic table. It's 4. How many each for each oxygen? 6. I have 2 of them. 6 times 2 is 12, plus 4 is 16 total. Explain which one goes in the middle. Is it oxygen or carbon? Carbon goes in the middle. Does anybody know why? Less electronegative. Good, class. Very good. Carbon goes in the middle. Oxygen, oxygen. Can you see that on there? Okay. Alrighty. What's
Can't
the
see
first
the
thing we're
second
gonna do,
oxygen.
sir?
Can't see the second oxygen.
We're gonna share. Remember, each time you share, how many is it? 2. 2, 4, and start on the outside and work your way in. Okay, 2, 4, 6, 8, 10, 12, 14, 16. Now here is the problem. Now the octet rule comes into play. Carbon is definitely going to need 4 bonds. Carbon needs to be surrounded by 8.
Why?
Well, because first of all, it is a nonmetal, which means it's going to share, it's going to want to have a valence electron, it's going to have 8 valence electrons. Much more so than boron. Okay? And because carbon and oxygen are actually closer to each other than chlorine and bromine are, right? Okay. So, carbon does not have 8 here. Is there a way that we can have oxygen and carbons both have 8 and still have no more than 16 total? What if we did this? What if we did this? What if we took these pair and did this? And we took these pair and we did this. Now how many would carbon have, Lexi? 2, 4, 6, 8. How many would this oxygen have? 2, 4, 6, 8. How many would this oxygen have? 2, 4, 6, 8. Each one of them would have what? 8. Okay? That, my friends, is called a double bond.
So how do you know when you're doing that?
How would you know when you do that? You mean double share? When all of them can have 8. When all of them can have 8.
So
Why did I do that with the previous one, BCl3? Because chlorine is so much more electronegative than boron, it's not going to share. It's only share one time, excuse me. It's going to share one time, it's not going to share 2 times.
So how do you know when it's 2 electronegative?
Because you have, then, I'll explain that later. That's going to actually have to do with having an electronegativity difference of greater than 1.7. Now, flip the page over. The first molecule that you're going to draw on there is SiO2. Okay, is Si in the same group as carbon? Yes. So I want you to try to do SiO2, please. Silicon has 4. Oxygen has 6. It's 12 plus 6, that's 16 total. Which one goes in the middle? Silicon. Oxygen's on the outside. All right, you guys make that work. Okay? Cut that.